Hi, okay. In this lesson, we're going to talk about how we're going to describe the motion of a kinematics graph. So, first of all, for the content, in this particular lesson, there will be 3 videos. In order to describe the motion of kinematics graph, which could be speed time graph, displacement time graph, distance time graph, or velocity time graph, you need to understand gradient and you need to understand it well. So I will devote 2 videos on the basics of gradient, which is this video, which is in red, the basics 1, and then followed by the second video, which is on basics 2. So if you are already familiar with some of the ideas that I'm going to share, you can skip any of the videos. So with this information, then we will proceed to the third part on how to describe the motion of a kinematics graph using this understanding of the gradient. So first of all, we need to define gradient. So what's gradient? Gradient refers to the measure of how steep a slope is. Okay, in math, it is measured by rise divided by run. So what is rise and what is run? So imagine with me if you have a graph where the line is running in this direction. So judging from the angle that it is risen, okay, obviously this slope is very gentle. When the slope is very gentle, it also meant that the gradient is gentle or low. So how do we know that the gradient is low? Because you have a very low rise divided by a very long run. So the low rise divided by a long run will give you a very small number. Now conversely speaking, if you have a very steep slope, okay, the gradient will be high or steep. There will be a very high rise divided by a short run. Okay. So the next thing we need to know is, what if now it is a flat horizontal line. Okay, if it is a flat horizontal line, obviously there's no gradient or it is horizontal. So when you have a horizontal line, the gradient is 0. Reason being, the rise is 0. When the rise is 0, 0 divided by anything will give you 0. Okay, then conversely speaking, the opposite is also true. If you have a vertical line, it means that there is basically no run at all. Okay, when there's no run, something divided by 0 gives you infinite. So a vertical line represents infinite gradient, while a horizontal line represents 0 gradient. Okay, so another thing we need to understand about gradient is that if you have a line that points to the top right, okay, it has a positive gradient. Another way to look at it is that the rise is positive. Conversely speaking, if you have a line that runs to the bottom right, or the rise is negative, that means instead of rising, it's actually falling, you have a negative gradient. So top right is positive gradient, bottom right is negative gradient. Lastly, we want to compare about what is considered a uniform constant gradient and what is not a uniform gradient. So if you have a straight line, okay, if you have a straight line, the gradient is considered to be uniform or constant, okay, because the gradient will be the same at any point along the straight line, because at any point the rise over the run will give you the same value. Conversely speaking, if you have a curved line, you have a non-uniform gradient, because at any point on this line the gradient is different. Now how do we prove this? Okay, we need to look at some ideas about curved line. For example, if you want to find a gradient at this point here, okay, first of all you need to draw what is known as a tangent line. So what is a tangent line? A tangent line is a line that just touches the curve at this point. Okay, let me introduce the tangent line. Okay, what happened is that this line just touches this point. It doesn't touch any point before or after. Okay, another thing to take note is that usually the tangent line will have equal spacing before and after the line to the curve. Okay, so you have about equal spacing. It shows that you have drawn an appropriate tangent line. So this tangent line will represent the gradient at this point. So if you can draw this line and then you find the rise over the run of this straight line, you will be able to find the gradient. So if let's say you want to find the gradient of the curve at different points, okay, let's say we find the gradient at 3 points. Okay, you can see that I've drawn 3 tangent lines here, but I also realized that after I've drawn these 3 lines, they have different gradients. This one and this one and this one doesn't point the same direction. So can you tell me whether this curve, alright, has an increasing or decreasing gradient? I'll let you think about it, and we will meet in the second video to discuss the answer for this. Okay, see you in the second video. Thank you.